What we're going to do today is an energy audit of my house. And our friends from CVC Mechanical are here, and Energy Solutions is going to take a look at my house and see how it can run more efficiently, correct?
That's correct.
All right, terrific. Thanks for being here.
Thank you for having us.
I appreciate it. And we're going to go inside. Come on along. Bill Metzger and Dean Bohartz are both Building Performance Institute certified auditors.
The BPI certification will assure you that we have met certain quality and safety standards and have received the appropriate training to do no harm when we're testing and evaluating your home. And we're obligated to provide you with certain levels of results of the testing, identify to you ways to help reduce your energy cost, and identify ways to help you improve your energy efficiency.
They started my audit by walking around the outside of the house with an infrared camera. This device helps them identify places where a house is losing heat to the outside. Once inside, they did a walkthrough of the house using the infrared camera. Let me tell you, it was thorough. Dean even went into my attic. The infrared camera picked up the lack of insulation between 3 studs in the walls of our bedroom. Notice the areas in blue. That's where cold air is moving into my house from the outside. Eventually, we headed to the basement, also known as the combustion appliance zone. Here, Dean conducted a series of safety and efficiency tests. We turned on the 2 bathroom ventilation fans, and we turned on my range hood. What are you doing now?
What I'm doing is I'm checking for negative pressure in the basement. It's more of a safety issue. Is what we want to have happen is we want to make sure that even if all your venting appliances are on, we're going to turn your dryer on as well. If you happen to be running all those things at the same time and your furnace kicks on, it can still vent all that dangerous carbon monoxide out the chimney.
Okay. That's good. So you're making sure there's no carbon monoxide building up in my basement if everything was running all at the same time.
Exactly.
Got it. At the same time, Dean also tested the efficiency of my furnace.
This particular furnace is probably rated around an 80% furnace. So the best that we're going to expect to see out of this is 80% no matter what.
Wow, that's kind of depressing.
Yeah, compared to a lot of your new high-end furnaces, which you're getting 93 to 95% out of.
Wow. So, because this is a gas furnace, if it was more efficient, I would use less gas, correct?
Correct.
To achieve the same heating.
Yep. Exactly.
Surprisingly, my furnace is running at 79% efficiency. Not bad given its rating, but certainly nowhere near the higher efficiencies now available in newer models. While he was in the basement, Dean also tested the water heater. The house passed all the safety tests with flying colors, no carbon monoxide detected anywhere, and all of it was adequately ventilated during the worst case depressurization test. Now it was time to bring in the blower door.
This tube goes to a sensor which is laying outside.
Yeah.
This is my sensor inside.
Oh, okay.
And I'm also measuring pressure going through my fan.
Okay.
With those 3 figures, I can calculate exactly how much air is blowing out through there.
Okay.
And however much air is blowing out through there, your house has to be leaking.
I'll admit that didn't make a lot of sense to me the first time he said it. Basically, for the blower door to pull 10 cubic feet of air out of the house, 10 cubic feet of air has to be coming in from the outside.
We can actually tell you how much leakage you have, then we'll compare that to the national ventilation standards for how much leakage you need for a house of this size.
Okay.
And see how much we can cut back that leakage to save you some energy.
Cool. It makes sense when you say it like that. With the blower door working, it was time for Dean to go back through the house with a smoke puffer to see where the air was moving. What you're doing now is you're simulating in 1 hour what my house would leak out in a whole day.
In a whole day.
So we've crunched time down by putting the blower door in.
Exactly. My
windows weren't too bad, but my front door definitely had some issues. This leakage, however, is considered good.
And every time somebody thinks about sealing up their home and becoming more energy efficient, they run out and buy weather stripping for the windows and doors. If you seal up the good leaks, it forces it to pull air from a much less desirable place, like through your attic insulation and things like that.
Ew.
Yeah,
okay.
And you know, where rodents crawl and all that kind of stuff. And
ew.
Not what you want.
Light switches and outlets are often places where air can infiltrate. Fortunately, gaskets are available to seal these areas. We really saw and felt the effects of the blower door when we got upstairs. Now my house is a Cape Cod, so the attic is under the eaves in the master bedroom. Can you see it moving?
Mm-hmm.
That's the air coming through the attic.
It's
holding
With
it
the
away.
blower door.
It's holding it away from the door.
Yeah. No surprise, Dean hit the mother lode of leakage in the attic.
Unfortunately, right at the moment, I have tons and tons of air just rushing through here. It's following that chimney chase right up through, and drawing all that air right through your closet and into your house.
This is of particular concern again because this is what they refer to as contaminated air. It is traveling through fiberglass insulation and bringing bits of that insulation into the house.
The insulation is coming down there.
Yeah.
Yeah, that's definitely a problem. That should all be tucked up and nice and tight. The other interesting thing with fiberglass insulation, it is a thermal barrier. Fiberglass insulation actually needs to be in contact with something in order to insulate. If there's an air gap back there, it's really not doing you a whole lot of good.
Dean had a good solution for keeping the unconditioned air in my attic out of the living areas of the house.
You can put in what they call a zipper seal, attic seal. Okay, is what that would be is you would open up your doors. You're still going to have your closet and stuff up above it, your shelves, which I'm going to seal off from down here to make sure none of this cold air is going up through there. But just inside of this door, mounted in here, there is going to be an insulated seal, which you'd have to unzip.
Oh, I've seen those. Where have I seen those?
In order to get into.
Cool.
So that's going to create an air barrier from coming through.
Yeah.
And it's also very well insulated.
Cool.
Okay, so this stuff out here doesn't become so much of a problem because it's not entering your conditioned space.
Right. Also keep the cat out.
There you go.
Remember the spot in the wall of my bedroom that had no insulation? Look at the effect of the blower door as it pulls the cold air in from outside. Notice the temperature reading for that section of the wall. Let's see what happens when I take my hand away. Can you see it?
Yep.
Oh, that's cool. Well, not really, because it's my house, but...
Well, in the really major problem with that is it's not an air leakage, but it's a very bad thermal leakage. So it works on much the same principles of a hot plate. You have a cold plate, so it's nice and cold, and it keeps radiating that cold into your bedroom.
We spent about an hour going over the house with the thermal imaging camera and the smoke puffer. The entire assessment took about 3 hours. I felt good knowing that my house was safe, and it was empowering to have an idea where improvements could be made to increase the efficiency of the overall system. About a week later, Dean was back with a comprehensive report on the results of my audit. The report is chock full of information about various technologies available on the market today. He reviewed these with me and did make one safety recommendation. That is to have a low-level carbon monoxide detector installed.
Carbon monoxide detectors, when they first come out, were all low level. And due to false alarms to fire companies and all that stuff, everybody called the carbon monoxide detectors going off and having all kinds of problems. They kind of dummied the carbon monoxide detectors a little bit. Your standard carbon monoxide detector now won't even register unless it's 70 to 100 parts per million.
Okay.
Before they signal an alarm. According to OSHA standards, if I come into your house and I test 10 parts per million of carbon monoxide, I'm back out the door. I'm not allowed to be in here.
10.
10.
But a regular one goes off at 70.
70 to 100.
The structure and exterior of the house looked good. Now it was time to find out just how much air was leaking into my house on a daily basis. The standard for a house my size with 4 people living in it should have 1,700 cubic feet of air moving through it. My house tested at 3,700 cubic feet. The attic and crawl space under my kitchen were the 2 largest offenders, and Dean recommended sealing these areas.
We will not seal up a house tighter than the ASHRAE standards.
Okay.
ASHRAE is a government organization that basically sets ventilation standards. That's what we do. We figure out the size of the house, how many people live here, and we want to ensure that we have enough good, clean, fresh air coming in to supply everyone.
Part of the report showed a cost comparison of taking the recommended actions. While it would be possible to replace my furnace with a more efficient model, Dean pointed out that it wasn't really the best use of my money.
You're looking at about a 20-year payback on that heating system for what it's going to save you. At this point, that's a very long payback. Really not worth doing. Your current furnace is doing pretty well.
The other recommendation was to deal with the surface insulation in the crawl space and heated area infiltration by cold air from the attic.
This type of repair not only is going to save you this money, but it's going to be much more comfortable. Your kitchen floor is going to be more comfortable. Your air is going to be cleaner. You're not going to have the drafts in your bedroom.
All the things that I now notice every time I walk through those rooms. At current energy costs, we could save about $316 per year. The remediation that Energy Solutions offers uses several different types of insulation, but the polyurethane spray foam is the workhorse that seals all the spaces and prevents the air movement into a house, thus making the entire system more efficient. Bill Metzger gave us a demonstration of this product using a cardboard box as a sample. I hope you now have a better sense of what occurs during an energy assessment. I will admit I was not sure about the whole thing, but now that I'm on the other side of it, I know it was money well spent. We've been given the tools to make smart energy choices and reduce our consumption. There is lots of information on the ERC site, including links for green jobs, energy conservation, renewable resources, and how to get your own energy audit. Other important websites with great information on conservation, electric choice, Energy Star ratings, government rebates, and tax credits for winterization are pplelectric.com and citizenselectric.com. Well, that's our show. I hope you picked up some helpful information as to how you can save money in 2010. Thanks for watching. Be sure to check out our Facebook site, and also be sure to email me with your story ideas, jenwakeman@ccn-news.com. I'm Jennifer Wakeman in your neighborhood.